Okay, so today we're doing the bookwork on standard deviation. Get out your graphing calculator or have your emulator ready because I want you to be doing the standard deviation with me in the graphing calculator. So, example 1, interpret the variability of a data set. The makers of a certain brand of light bulbs claim that the average life of the bulb is 1,200 hours. The lifespan in hours of a sample of brand A light bulbs are shown. How close to the claim were the light bulbs in this sample? So basically it's saying that the average lifespan is 1,200. So that means that that's the mean. So X bar, that's the mean, is 1,200. Okay, that, I don't know why that looks so crazy. Okay. Whew. All right, 1,200. Okay, now we're going to calculate the standard deviation. So to do that, just a reminder if you forget, you're going to go to Stat, Edit, then you're going to go up, Clear, down to clear out your column if you have values in there. You're going to type in all of these values. So 1,050, 1,231, 1,305. So just keep going, keep typing in all of the values. Do this with me. I hope I don't make a mistake because I'm trying to go fast. Okay, on to the next row. One, 2, 4, 5. 1, 2, 8, 3, 1, 2, 2, 5, 1, 1, 8, 5, 1, 2, 7, 5. I really hope this is right. Okay, then you're going to Stat, over to Calc, and then you press Enter for one of our stats. I have to press Enter a few more times. Okay, mean is 1,200. All right, so it must be right because we got the same mean. And then you have two standard deviations here. If you're talking about a population, population means that this is all of the data that there is. You're going to use theta x. If it's just a sample, meaning like there was a lot more light bulbs tested, but they're only taking a small piece of it and just saying, here's our sample of light bulbs tested, then you want to use SX. So sample, you use SX, okay, which is easy to remember, I think. And it says in the problem of a sample, so we have to use SX. So SX, the standard deviation, is 75.5, about 75.49, 75.5. Okay. So basically, this number tells you, on average, how far apart all of the values are from the mean. Okay, the next question. What does the display reveal about the data? So we're just going to look at this, nothing to answer here. This is symmetric, basically. The data are normally distributed. The most useful measure of spread is standard deviation. Standard deviation is a measure that shows how the data vary or deviate from the mean. Now we're going to talk about how many standard deviations the values can be away from the mean. So basically, one standard deviation away from the mean is 68% of the data. So one standard deviation higher than the mean and one standard deviation lower than the mean, that's where 68% of the data fall. And to explain what that means, like for instance, we had a mean of 1,200, right? We had a mean of 1,200. So you take your mean, and then what you'll do is you'll subtract 75.5. So 1,124, that's one standard deviation away from the mean. And then also you want to take 1,200, you want to add 75.5. And then that's a standard deviation higher than the mean. So that's one standard deviation from the mean is that range. If you want to do two standard deviations away from the mean, you just add another one. Okay, so it says the mean of the data is 1,200. Light bulbs with a lifespan between 1,124.5 hours and 1,275.5 hours lie within one standard deviation of the mean. So that's what we just did. In a large sample, randomly, among such light bulbs, we would always expect 68% of the lifespans to be within one standard deviation of the mean. thanks to the predictive power of the normal distribution. If the data is not normally distributed, it's not really the 68%, 95%, 99.7%. Okay, what is the lifespan of light bulbs that are within 2 standard deviations of the mean, within 3 standard deviations of the mean, question mark. Okay, so basically what you're gonna do is you're gonna take the mean, which is 1200, you're going to subtract 75.5, that was our standard deviation, right? 75.5, yes. And then you're gonna subtract 75.5 again. That is 2 standard deviations away from the mean, lower than it. So you're gonna do 1200 minus 75.5 and then minus 75.5 again, and you're gonna get 1049. Then what you're gonna do is you're gonna take 1200 and you're gonna add 75.5, and you're gonna add 75.5 again, okay? 2 standard deviations. So 1200 plus 75.5 plus 75.5, and you get 1351. So this means that 1049 to 1351 hours is 2 standard deviations from the mean. Now it asks for 3 standard deviations from the mean. So all we have to really do is we just have to subtract one more 75.5 from this one, and that'll get us 3. So 1049 minus 75.5, and we get 973.5. So 973.52, and then we're just going to add one more standard deviation to this one, so 1351 plus 75.5, and that's 1426.5. So 973.5 to 1426.5 hours is 3 standard deviations from the mean. Okay. Next, example 2 shows you how to calculate the standard deviation of a sample. I'm going to show you how to do this longhand, but you know, using your graphic calculator is really the best thing to do. So, the table shows the number of cars sold by an auto sales associate over an 8-week period. How much variability do the data show? So when it's talking about variability, it's asking about the standard deviation. The higher the standard deviation, the more variability there is. You can use you can find the variability by solving for standard deviation for a sample, which is this formula, okay? When we find standard deviation of a population and not a sample, we would divide by n instead of n minus 1. So remember, a sample means that basically there was a lot more cars sold than this, okay? But this is just a sample of the data. There might be 1,000 values and they just took a tiny little sample of it, and that's when you do sample standard deviation. So the first step is to find the mean, so we need to add all the values together and divide by how many there are, or you can simply just type it in your calculator, up, clear, down. You can just type in all your values, 18, 25, 18, 10, 17, 15, 18, 15. And then you'll go to stat, over to calc, 1var stats, enter, 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 and the mean is 17. X bar is 17. Okay, now how you do this longhand is you're going to create a table. First you're going to list all of your values. So 18, 25, 18, 10, 17, 15, 18, 15. X bar, 17, 17, 17, 17, all the way through. Then X minus X bar, so 18 minus 17 is 1. 25 minus 17 is 8. 18 minus 17 is 1. 10 minus 17 is negative 7. 17 minus 17 is 0. Negative 2. 1. Negative 2. Now you want to do x minus x bar squared. So you want to take these values and square them. 1 squared is 1. 8 squared is 64. 1, 49, 0, 4, 1, and 4. Simple. Okay, find the variance. The variance of a total population, often noted sigma squared, is the mean of squares of the differences between each data value and the mean. When finding the variance of a sample, it's often denoted s squared. By dividing by n provides too small an estimate of the variance of a population. This is because data points from the sample are likely to cluster more closely around the sample mean than the population mean. So that's why we divide by n minus 1 when we're doing a sample. Anyways, so the variance is what you do. So s squared equals, you add all of these values, so 1 plus 64 plus 1 plus 49 plus 0 plus 4 plus 1 plus 4, and then you divide by n minus 1. So we have 8 values, 1, 2, 3, 4, 5, 6, 7, 8. So n minus 1 is 7. Okay, so s squared, when you put that in your calculator, add all these up, divide by 7, you get 17.71. The last step is to take the square root. So you're going to take the square root of 17.71, and you'll get s equals 4.21. This is the standard deviation, sample standard deviation. Next, the table shows the number of cars sold by auto sales associate over the next 8-week period. How much variability do the data show? Okay, so we're just going to use our calculator for this. We're not going to do it longhand. Not necessary. Okay. Clear, up, up, clear, down. Okay. Type in all your values. 12, 14, 29, 10, 17, 16, 18, 16. Click stat, over to calc, 1 bar stats. Okay, so basically x bar is 16.5. The standard deviation, and we're going to use SX, okay? We're going to use sample. I'm assuming that this is still dealing with a sample. It's a very small amount of numbers, is 5.7. Basically, how much variability did the data show? So the standard deviation is 5.7, and this standard deviation is higher than the previous standard deviation of 4.21. All right, last but not least, there's no work to do here. I'm just going to show you this. So find the standard deviation of a population. So what's different about finding the standard deviation of a population is this is all of the values. This is all of the data. It's not a sample of data. It's every data value that was collected. And when it's every data value that was collected, you divide by n instead of n minus 1. That's the only difference. And in your calculator, instead of using SX, you would use sigma x, and that's population standard deviation. Okay, so when you're doing your problems in your book, you want to read if it's a sample or a population, because you're going to use two different numbers depending on what it is. That's super important. So basically it just shows you how to find the standard deviation longhand, but we've gone over that in the calculator. But you would use sigma x instead of SX. And then here's a concept summary that I thought was good. It's got the formula for sample, formula for population. It talks about standard deviations away from the mean. And that is it. Okay, so you're going to do some practice problems, submit them to me, and that's it for today. Bye.